We are delighted to bring you this seminar presented by LabRoots. Welcome everyone, and thank you for joining today's keynote presentation titled Pattern Evidence Reconstruction. It's my pleasure to introduce you to our speaker today, Dr. Henry Lee, a Kai Professor, University of New Haven, Chief Emeritus, Connecticut State Police Director, and of the Research and Training Center. For a complete biography on our speaker, please visit the tab button at the top of your screen. If you have any questions that arise during the presentation, we encourage you to submit your questions in the Q&A box. Our speaker will address your questions following the presentation. As a reminder, this presentation is educational and offers free continuing education credits. Click on the Continuing Education Credits tab located at the top right corner of your presentation window and follow the process to obtain those credits. Please join me now in welcoming our keynote presenter, Dr. Henry Lee. I will now turn the presentation over to him. Welcome, sir.
Good morning, everybody. Today, we're going to talk about pattern as evidence. As you probably know, the criminal investigation at the crime scene, forensic scientist, police officer, detective, will often go through the central dogma of a forensic examination. Forensic science is a little bit different than other scientific fields such as chemistry, biology, molecular biology, immunology, or even medicine. We separate our work in three stages. The first stage called scene processing. Scene processing starts recognition. We'll have to recognize the potential evidence. Not everything at the crime scene is physical evidence. So recognition is the first step. Once you recognize this potential evidence, you have to document, preserve, and collect. The next stage is laboratory process. Those collected physical evidence is submitted to the laboratory. We through identification, comparison, and with instrumental, biological, physical, other type of examination, comparison, and individualize that particular evidence. From there, the third stage of is court processing. We have to transmit our report with the documentation to the court of the law, either through the prosecutor or the defense attorney into the court. Once the evidence introduced to the court, we'll have to testify. And we not only testify our result, but also make interpretation and reconstruction. Physical evidence come from all different forms. There are so many different ways to classify the physical evidence. I generally put into the following 7 categories. Transit evidence, which means something can change quickly. Pattern evidence is what we're going to address today. Then conditional evidence, transfer evidence, associative evidence, electronic evidence, and medical evidence. Last lecture, we already covered all those, but today we're going to talk about pattern evidence. What we're going to do today, we're going to talk about what is pattern evidence. How is it involved in crime scene? What type of pattern evidence can be found at the crime scene? And where to find it? How to find it? How is it collected? how it should be handled and preserved. How is it examined? And what's the evidential value of those pattern evidence in investigation? And the last, we're going to cover pattern evidence reconstruction. What is evidence, pattern evidence? There are so many books, paper published, give all different meanings, definitions, procedures. Pattern evidence generally created from different objects when they have a physical contact with a surface to surface and leave behind some imprint, impression, indentation. Evidence, pattern evidence can be visible or latent. May find a variety type of object and surface. There are guidelines from NIST and OSAC. So the examination of those physical evidence should follow the national guideline. What is crime scene reconstruction? The crime scene reconstruction is the scientific analysis of a crime scene, using pattern evidence, logic, physical evidence, the result of testing, laboratory testing, to test a hypothesis about what did happen, how did it happen, what did happen, what the sequence event at the crime scene. Crime scene reconstruction, usually we need the following: laboratory result of physical evidence, scientific analysis and observation of the crime scene, recognition and interpretation of the pattern evidence at the scene, then systematic study of any other related information, utilize the big data, develop a logic hypothesis. Then we use scientific result to test those hypotheses until we come up with a viable theory. That's called crime scene reconstruction. Here is an example. I was called to the scene at the noon time. Initially, it looks like a traffic accident. However, the crime scene pattern indicates it's inconsistent with a typical traffic accident. A car, vehicle in the middle of the parkway, victim's body found next to the vehicle with his pants down. Of course, that's against the common sense. How many drivers drive a car with pants down? In addition, we noticed victim was shot twice behind the head. There are 2 bullet holes found in the windshield. With all those patterns indicate to us this vehicle probably have 3 occupants. The victim more likely is sitting in the front driver's seat. The shooter is from the behind in the back seat based on the trajectory. So just look at the pattern. We already developed a hypothesis that's more likely it's a homicide. It's not a traffic accident. 2 suspects, more likely in the woods, are left the scene already. So with that, we start look at it, the pattern evidence. Usually, where can we find those? Impression made in soft material or surface, such as soil, sand, snow at the sea. Indentation or damage made by force onto a surface. Imprint made by dirt, dust, soil, deposit on a flat and hard surface. Impression made by object with the dust or wet, wax, greasy surface. Imprint made by transfer of blood, body fluid, ink, or grease like a material, a ink-like material. For example, an outdoor crime scene. 8 investigators, some step on a soil surface, some step on a concrete surface, other on the grass. Each of them left some imprint, impression, or indentation. Another example, a breaking robbery case. We look at the glass, the fragment, and fracture mark that tell us the direction of the force, the type of material used to break the window. This is a vehicle involving a crime left behind the scene. So on the surface of the vehicle, as you can see, different type of mark, the roof, all those are pattern evidence. We use a laser light source, try to examine those patterns. Pattern evidence can also found on another piece of physical evidence. For example, this is a plastic bag, but on the bag, we can see fingerprint, we can see folding mark, we see writing, all kind of those are formal pattern evidence. This is a homicide scene. Of course, we can see blood pattern, handprints, and of course, the damage pattern on the wall. So pattern evidence actually consists so many different categories, such as fingerprint, handprint, glove, sock print. I just want to give you some example. Even ear, nose print, bite marks, handwriting, wounds and injury, blood pattern, fabric pattern, body condition, ammo pattern, modus operandi. This means method of operation, and voice print, fire burn pattern, tire track marks, tool mark, cutting mark, machine mark, weapon, bullet casing, GSR pattern, trajectory pattern, even instrumental data. For example, GC chart, mass spec chart, those are pattern too. Stamp, type, all those are patterns. Those patterns, some we're familiar with, such as fingerprint, striation mark on the bullet, tire mark at the scene, or a blood stamp pattern. Some of the pattern which we use for identification. For example, a fingerprint, we want to compare the fingerprint known records to identify the individual left the fingerprint. The bullet striation mark, we want to associate to certain type of weapon. Tire mark, same thing. Blood pattern, besides identify the source of the blood, in addition, we can see this blood still not complete dry. It's semi-coagulated. That gives us indication how long those blood been shed. Those are patterns for reconstruction. For example, this lock was on top of the blood, which means after blood deposit, this lock was broken. So with that in mind, pattern identification, for example, handwritings, palm prints, fingerprints, cutting mark, we can identify the type of cutting instrument. With a mass spec or even DNA, that's also a pattern recognition. We recognize the pattern. Those pattern is for individualization, to identify certain drugs, certain body fluid, or an individual DNA. But there are some marks, patterns we use for interpretation. We know those are sharp instrument left some injured mark. We can make interpretation, the direction of those mark was making, and whether or not made by another individual or by the victim, him or herself. Even a college test, exam, we can look at an exam paper to determine the erasure and look at the marking, whether or not made by the same pencil or by same individual, those marking and erasure. Of course, those are just interpretation. You cannot really trace to the source of origin. In between this is pattern reconstruction. For example, a fire, when I get there, I notice there are 5 origins. Dark red, those indicates probably 700 to 900 Fahrenheit. Cherry red, the temperature indicates about 1100 to 1300 Fahrenheit. Yellowish cherry red is hotter, about 14 to 1500. Yellow, which even higher now, bright yellow, that's probably got to 2100 Fahrenheit. So from the pattern, we can recognize different origin, different temperature. That's a suspicious fire. Through the burn pattern, we can also make interpretation, the direction of the fire, melting objects, what type of temperature can reach at the fire scene, those objects melting. Left behind, the shoe print can tell us how many people and what the direction. Here another example of a homicide scene. The blood pattern, the deposit of the towel, and the blood floating pattern, and no blood at the west basket, blood smear on the countertop. Each of those give us some information about this crime scene. So where and how to find the pattern evidence? Obviously, at the crime scene. Crime scene can be as huge as the whole airport or a whole house, can be as small as a piece of hair or fingernail, you may have pollen particles. So how and where we can find evidence? Before we talk about how to find evidence, we want to know something called linkage theory. In late 18th century, we all know something called Lacar's transfer theory. Lacar is a well-known forensic scientist. He came up with that theory when two objects in contact, they have a mutual transfer between the border. The linkage theory is slightly different. It's built on Lacar's theory of transfer. We have to consider the victim, the evidence, and the crime scene, and suspect the four-way linkage transfer. Victim can leave the evidence at the scene, and also suspect contact the victim can have a mutual exchange of the material. Also, we have to consider so-called secondary transfer. Even no direct contact may have transfer too. So once we know this linkage theory, so where to find it, that's become elementary. Of course, at the crime scene, the point of entry, point of exit, pass to target area, to target area, we can find pattern evidence or physical evidence, such as object, clothing, tools, locks, door, window, safe. We can find a body. Later, I will give you some example on somebody, victim's hand, suspect's hand. For example, gunshot residue pattern on the suspect's hand can tell us the individual may discharge or handle or touch a firearm. The distribution of the gunshot residue on victim's body, we can estimate the distance between a barrel to the target area. So at the crime scene, we look for pattern evidence, point of entry. That's the area usually leaves some evidence. How we find it? Generally, if the pattern is visible, that's much easier. But many times, the pattern evidence is not so visible. We have to use lighting, dark the room, use side lighting, helping us to look for pattern evidence. Sometimes we have to use chemical filming technique. For example, a vehicle. We know more likely a person enter the vehicle may touch the frame area. So we try to search those areas for pattern evidence. Once you recognize, identify those pattern evidence at the scene, we have to protect those evidence, generally cover the area, avoid contamination or step on it. Otherwise, the case is going to have difficulty. For example, the famous O.J. Simpson case, DNA found at the scene. Scientifically, no doubt in my mind, I review those DNA results from Los Angeles Police Department, Department of Justice, and other laboratory, DNA laboratory testing. So when I testify, I say the DNA, in fact, is contributed and by O.J. Simpson, except the evidence was collected, item 48, 50, 52, June 13, June 12, they collect, June 13, dry overnight, June 14, they start sampling, did the serological test, then DNA extraction, DNA testing. However, when we examine the evidence, I noticed their pattern evidence, so-called blood imprint on the packet, which means something have to transfer those patterns. Even today, we still don't know how those patterns get on there. Another example, 2 drops of liquid was found on a walkway. DNA is O.J. Simpson's. However, 1 drop is complete dry, 1 is wet. If 2 drops would deposit at the same time, same day, same temperature, same environment, from the same person, same receiving surface, that 2 drops should be the same. But have pattern tell us different. Of course, injury pattern, shoe print pattern, the boutonniere broken. This pattern, those patterns indicate a struggle, and those are some defense wound. So pattern evidence play an important role in the outcome of the case. How to find it? Basically, we follow a systematic and logic examination of the scene. We darken the area, use a strong highlighting light sources, search the area with oblique lighting. We enhance the suspect pattern with variety of scientific method. Later, we're going to cover that. So at the scene, the first thing we have to recognize, this is a triple homicide scene. We found casing. The casing ejection pattern give me indication the shooter's location. The casing also tell us itself that fire from a semi-automatic weapon. The shoe print, the stuff left behind, each of those patterns yield information. So at the scene, the investigator and forensic scientists, we have to recognize and understand the importance of evidence, especially the location of those evidence, the pattern, the condition. We have to document thoroughly. So crime scene investigation, not just pick up the evidence, put in the evidence bag. We have to photograph, document those pattern evidence. We generally start with an overall view. Then we should photograph the evidence with scale, then take close-up photograph. We also have to take measurement, sketch, and documentation. We should follow the guideline. Documentation, generally with an overall view, then move to a closer specific area, then we photograph with scale. Once we finish the initial documentation, then we have to look at the close-up and document those imprint evidence, we say implant, use different photographic technique, can be direct lighting, reflect lighting, bounce light, or side lighting. This can be covered in a different lecture. So crime scene photograph, as I indicate before, start with overall view, then intervene media, then close up, photo with scale, then evidence photo. Always have to do the sketch and notes and videotaping. Enhancement of the pattern can be photographic method, use oblique lighting, UV light, alternative light source, then use powder dusting or chemical reagent or a combination with a newer procedure. We can also do image enhancement. That's an example of side lighting, UV lighting. Now have so many different light sources we can use at the crime scene, can helping us discover those patterns and document those patterns. A hit and run case vehicle. When we examine the vehicle, we notice some damage in the headlight area. But very important is this area, we found a fabric pattern. That's victim's pants. So although we cannot say definitively from that pants, but that gives us the similar wave pattern, similar measurement that could have resulted from the victim's pants. This case happened in New York. Nassau County, a homicide detective come to our institute, took a course of pattern reconstruction. When he back to his department, he was called to the scene, an attempt rape case. That's a female college. Suspect apparently entered the shower room through the window. That's the shower stall. Victim fought the suspect and chased the suspect away from the scene. Detective Wing used the alternative light source, was able to discover this shoe print pattern. From that, he was able to link one of the workers working in college and solve the case. With the initial photograph, visible light, very difficult to see the pattern. With the side lighting, UV enhancement, then you can discover that. There's so many different enhancement reagents. Review of the literature, there are more than 20 commonly used chemical reagent we can use at the scene to enhance. Generally, we fall into the following, in those reagents falling into the following 7 categories: powder dusting, chemical reagent can react with heme. Heme is a molecule of the hemoglobin, which in the human blood or animal blood, any blood source, you can use that. Or protein enhancement reagent, body fluid enhancement reagent, vegetative material, and chemical, elemental, enhancement reagent. Here, an example, use powder dusting. We develop this pattern evidence. Blood enhancement reagent, such as orthotolidine, phenolsaline, tetramethylbenzidine, locomolecular green, luminofluorescein. Those are some commonly used. Orthotolidine, because that's potential carcinogenic, should not use, which we can enhance. When you select the reagent, basically you want the best contrast. Look at the substrata, the receiving surface. Try to find a maximum contrast so you can document those. This case is a homicide case happening in Ohio, and the suspect left a partial shoe print on a sheet, which not really visible. However, after we use chemical enhancement, we can see the sneaker, the chevron pattern. Also, you can use fluorescence chemical to enhance. Another major category is use protein enhancement reagent. From colors reagent react with amino acid or protein, become a color compound. Commonly used reagent are Linkage, amino black, crystal violet, DFO, chromatic blue, and Linkage analog. For example, this is a case I called to the scene, and we was able to develop a pattern on the victim's body. Subsequently, through the body, we was able to reconstruct the scene and solve the case. Now, after you develop, you recognize what you're going to do with those pattern evidence. Of course, first to photograph, document, do all the measurement at the scene. The next thing, try to lift or cast or dust and collect. If the area, you can move that piece of evidence, preferable is move the complete piece of evidence, sent to the laboratory to examine, such as broken glass or window or closing, floorboard. If a certain surface you cannot physically move, then you maybe cut the piece and to submit to the laboratory. So basically, that's the 4 different ways: photograph, documentation, collect the item, remove the object, cut the surface with the imprint. So it depends on the situation. Then we make a decision what to do. Of course, there are certain special lifting technique, such as use gelatin lifter, use electron static lifter, or gel mold, casting, and different material. Now, once you lift the evidence or cut the evidence or submit the evidence, how you preserve and handle? Of course, you have to handle with care. You don't want to destroy the pattern. You don't want to remove or clean or modify or change the pattern. You have to place the suspect item, create that pattern in a separate box instead of mixed together. Also, you should package separately, carefully, And nothing more important is document thoroughly before you do any lifting or cutting. So documentation, photographing is very important. Now we covered recognition of pattern, identification, document enhancement, collection. Once the patterns sent to the lab, generally laboratory examiner will look at the pattern. Is this a two-dimensional, three-dimensional? Is that visible, latent? What's the direct class characteristics? What's the individual characteristic? If you leave in a flat surface, generally we say that's a two-dimensional. You start with not visible, after we enhance, become a visible piece of evidence. In addition, we also notice there are sequence, two type of a pattern deposit on top of other. At the scene, you can also find three-dimensional evidence. You should photograph, document, and make a casting. Don't put your tool directly into impression area to try to fit that. Not going to cause the contamination. So pattern evidence doesn't matter imprint or impression. It can be deposited by human, such as fingerprint, footprint, lip print, ear print, handwriting. Can be animal or vehicle, clothing. I should have a G here, and objects, such as tool mark, bullet, typewriting pattern. Even on human body, we often find pattern evidence. I'm sure you probably have an idea what kind of pattern. I'm sure most of you think that's cigarette burn. Actually, you look at the size and pattern, not actually a cigarette burn. Anybody have any idea what kind of pattern? Later you can ask me if you don't know. The next one, of course, that's a bite mark. Bite mark, before you do anything, you should photograph and document and collect saliva and DNA evidence. Imprint reconstruction, often you can find out a vehicle. For example, this vehicle, we can find static transfer evidence. It shows the seat have some kind of a material was put there, left this pattern. Here is another pattern. That can give us some idea what's there. Some are difficult to identify. Others are pretty easy. For example, this one, everybody can tell me that's a hammer. Many times, hit and run case. For example, this case happened in Taiwan. This is a suspected hit and run vehicle. On the vehicle, there are some pattern here. Of course, very difficult to read it, but after enhancement, we can easily tell that's a 3, that's a 5, that's a 7, OVT, and that's from the victim's license plate. There are also sometimes at the scene we found so-called dynamic contact pattern, which indicates certain force was involved. For example, this tool mark shows us the direction of the force. For example, this blood pattern and medium velocity blood cast pattern can give us information, what type of a weapon, what type of direction, the shoe print, the movement, the contact, all of those are example of dynamic force. So what is the evidence value for pattern evidence in investigation? Obviously, you can link an object or vehicle to the pattern. You can link a person to the pattern evidence to the scene. You can confirm or refute a statement. You can link a person, a vehicle, or weapon, or any object to a case. You can help to reconstruct the crime scene. You can develop the investigative lead. For example, the blood pattern found a suspect's clothing told us this individual was involved in the bloodshedding case. His statement to police say he did not know anything. So obviously the pattern tell us otherwise. The blood pattern shows us this is a bare footprint, indicates the individual walk on the concrete surface, did not wear shoes. This is an indentation, show us a work boots, the brand name of the work boots. Anybody have any idea what's the brand name of the work boots? Of course, this is one of my best case. Here involve a homicide case. This is the vehicle. Of course, everybody can see a key and a key ring, which indicative something happened given the distribution of these two objects. Indicate to us is separate from a key ring. That's more likely it's a door key. However, when we examine the car seat, that's the key, that's the key ring. But I'm sure some of you see here have a pattern. That's the pattern, which indicative the key was initially was here. Somebody sit on the seat and the key adhere to the pants, deposit to here, and this is the original location. So pattern evidence can really helping us to reconstruct. For example, this is another Connecticut tragedy. A truck hit a police officer and took off at the Highway I-84. The investigators stopped all the vehicle. I was called to the scene. This is one of the vehicle stopped a truck. Under 160, we see a pattern. Usually hit and run case, we look for blood, hair, tissue, fabric, but this area did not find any blood, hair, tissue, and fabric. Under sidelighting, we see this pattern, but not visible. Use chemical filming. With sidelighting, we develop a trooper's shoulder patch. That's the victim's Sure. So with a single piece of pattern evidence, we was able to link the suspected vehicle to the victim and determine the sequence event and reconstruct the case. So general principle in physical pattern comparison. After we recognize and identify, so we can do a direct physical match, or we can include it, or similar, or consistent with, or we can exclude, or we can cannot reach a conclusion, insufficient detail, or we call inconclusive, or we can exclude some pattern or dissimilar. So again, this interpretation and the report, you should follow the guideline and should meet the core test. This is the suspect's shoes, and that's the piece of evidence, the sneaker print on a piece typed the paper. Obviously, we say we exclude that. It's not the suspect sneaker left this pattern. That's just easy. Identification, we can say that's similar pattern. However, is this from that shoes? Unless we have significant individual characteristics and very difficult to call. So matching is a term very difficult to use. Is this a match? Of course, the striation, the inclusion, the mark, it shows that could from the same origin, except now courts sometimes require statistical information, error rate, many type of pattern evidence we cannot produce. For example, that trooper's shoulder patch found on the truck. In my whole career, we only have one case. I cannot really say statistically how likely that will produce. Reconstruction is the ultimate goal for pattern evidence. So at the crime scene, if we can reconstruct, that can give the investigator a lot of investigative lead and value. What type of reconstruction we can do with pattern evidence? We can look at a location of the pattern. We can look at the condition of the evidence, amount of evidence, distribution of the evidence, the sequence, whether or not those are contaminated or altered. We can identify, we can interpret it. For example, we can determine how many tire track. Obviously, we can see two. This is on top of this, and so you know two different vehicles left them. There are also some other patterns. So at the scene, those patterns we can study, provide investigator some valuable clue. For example, the vehicle made a turn, the direction, and of course, if the pattern have sufficient individual and class characteristic, then you can link the object. Many times, the pattern evidence can help us to eliminate certain things or to include certain individuals. This There's a case happening in Hawaii for college student on spring break. Somehow the vehicle, as you can see, left a mark, lost the control down the cliff, caused a fire, and 4 body was commingled. Victim was identified through dental chart and DNA. That's the easy part. However, later become a major litigation. Who is the driver? This is one of the victim's shoes. Underneath of the shoes, as you can see the pattern. That's the brake mark. So we know this individual have a contact with this brake, left this mark. Often at the scene, we also can tell how many people. For example, this scene, we see 2 types of shoe print. So tell us at least 2 individuals were involved. Also, the pattern can give us indication what the size of the shoes, what's the possible height, what's the possible brand, name of the shoes. This case, victim's body was found on the kitchen floor. Of course, the blood smear pattern indicates us the crime scene was altered, which suggests the suspect tried to clean up the scene. The blood pattern evidence predominated on the top of her garment, and which indicative she was on the ground and stabbing occurred. There are also some blood smear, blood imprint. We was able to enhance at the scene, that give us the partial shoe print. That's a close-up for the shoe print. And of course, through the data analysis, we was able to identify the type of shoes, and subsequently the investigator was able to link the suspect, not only from the pattern evidence, also the trace evidence, the blood stamp, DNA on suspect shoes, and the pattern evidence, of course, that's the area, enhanced, that's the ink print, that's the suspect's shoes. So basically, use pattern evidence, link the case, and use DNA, and link the suspect. We can do event reconstruction. For example, this is another crime scene. We have a tremendous blood at the scene, victim's body. Of course, the drawer open and no blood inside the drawer can tell us quite a bit information. On downstairs kitchen floor, we found some pattern. After enhanced, we know suspect wear a work boots and walk around the scene. Was subsequently the case was solved. This case happened in Florida, and at the scene we see some footprint from the pattern. We can determine the person's stride, also the person more likely male, female, walking or running. Those are the pattern interpretation. but in between have a blood which indicative have some blood source, make of those vertical deposit and some pattern at the scene, broken pieces of material, and also large of the amount of blood that is no center, so-called glow spring. Those material give us information. More likely, somebody coughed out the blood, and we was able to reconstruct. And of course, they gave me a nickname, call me King of the Crime Scene. Now time is up. The last test. That's a pattern. This case, the victim was a college student, reported to police. She was sexual assault by her former boyfriend. Not only sexual assault her, also carved a heart in the palm of her hand. The boyfriend was arrested, and the boyfriend said, no, I did not do that. I did not sexual assault her. I did not carve the heart. She is crazy about me. She want me to marry her. I refused. She did herself. This pattern helping us to look at both persons' statement, which one is more likely true. Okay, so with that, I turn put into Susie. We finished today's lecture.
Let's start with our first great question coming in. We have some wonderful questions coming in from our audience members. Dr. Lee, for how long is evidence preserved?
How long evidence preserved? That's two different answer. One is at the legal stage. Each court, state, or federal case, for example, homicide evidence should preserve forever. Many cases early days, for example, sexual assault, only 5 years, statute of limitation. Now they extended longer, then you have to preserve longer. Scientifically, in the laboratory, when the police submit to the laboratory, if under laboratory custody, laboratory have to preserve in that period of time until release to the submitting agencies.
Thank you for that. And how do you establish the identity of the person in a sexual offense with help of the Asmoperia permia semen?
Okay. In other words, the question is, if somebody doesn't have sperm, all right, their ejaculation has no sperm. However, they still have cells, body cells, in their seminal fluid. So you still can find DNA. In addition, you can find protein markers. You can always do protein markers plus recover some cells to do PCR, to enhance STR, and do DNA analysis.
Thank you very much. When new shoes are made, is a pattern of the bottom supplied to the database somewhere voluntarily? I wondered about this as well.
Good question. Good question.
Yeah.
On early days, you know, I already retired 5 times, so I don't collect shoe prints anymore. Early days, my career, we collect shoe prints. and we write into the manufacturer, ask for you give us a exemplar. We goes to shoe store to look at the pattern. Susie, to tell you, early days, I don't remember my wife's birthday, but I do remember the pattern. At the scene, I can look at the pattern. I say, aha, that's Puma sneaker. And of course, today have big database. A lot of commercial company, they have this database available. A lot of laboratory and different country all have database. So hopefully someday, I don't know, maybe they already exist, have a world big database so everybody can use that.
That would be great, huh? Dr. Lee, what was the pattern on slide 85?
Slide 85. Okay, I have to look at just bear with me a second. I have to look at slide 85. Look, 85 是哪个?
I believe it was the one that you said, ask me later. It had the two marks, the small marks that we misinterpreted as cigarette burns. And you said, ask me later.
Yes. That's 84. This is 85.
Okay.
Okay. That's a good question. What kind of mark?
Oh, and it looks like we may have lost Dr. Lee for a second. I'm sure that he will be right back. We apologize for that. Sometimes we have these little moments of errors in technology. I am sure this happens all over the world, and each of you have experienced this in the past. So we apologize.
Okay.
Here he is.
Okay. This is a sucking mark. It's not the teeth mark. It's a mouse. Contact the surface.
Interesting.
Yeah, very interesting mark.
And thank you for that. And again, audience members, thank you for your great questions coming in. Dr. Lee, what is the most common manipulation of evidence that forensics would encounter?
Can you ask again, what's the most common?
What is the most common manipulation of evidence that forensics would encounter?
You mean somebody else manipulate the evidence, or?
I believe that's what they're asking.
Okay, most of the time people try to add some more or try to remove. For example, cleaning, washing, destroy the evidence. Many times they threw in some curveball. For example, we do have a case, somebody wears somebody else's shoes, left some shoe print at the scene. Or, of course, many times they put the different people's clothing and trace evidence at the scene.
Thank you for that. And Dr. Lee, how do you process latent fingerprints on concrete surface? That's the first part of the question. And which method is most useful for developing latent finger marks on such surfaces?
What surfaces? Second portion.
On the concrete surfaces.
Okay. Concrete surfaces depends on the concrete. If a rough surface, you cannot find a readable fingerprint, usable fingerprint. Maybe we can use chemical, develop the size of the hand or size of the finger, make some interpretation. If a smooth surface, generally we can use fingerprint powder or use cyanide acrylic fuming to develop the pattern.
Thank you for that. And how many evidences are presented in court before a crime is proven, like a homicide, for example?
Okay. Excellent. Oh, those questions are excellent. You know,
aren't they great?
Those are great questions. This is also a question should not ask a forensic scientist, because people think the movie and television show think the forensic scientist will start from the crime scene, will work in the lab, will goes to court, we're dictating the outcome, how many pieces present. But forensic scientists actually, in a legal setting, we're not like the movies. Most of forensic scientists doesn't go to the scene. I'm the few exception. The crime scene usually handled by detective or major crime squad or crime scene technicians. When it goes to court, not say we want to say what we want to say, what to present. Usually the lawyers, the district attorney decide what to present, what the sequence to present, what question they ask you. If you're a defense expert, you call to the court. They just present one or two pieces in favor of the defendant. They only ask a few questions. Nobody wants the whole picture, whole story. The forensic scientists, we just like a piece of a music instrument in the courtroom. Depends the musician and the conductor decide. The conductor basically is the judge. So a lot of media coverage criticized the forensic scientists. We're not scientific enough. We don't know what we're doing. But if you look at it carefully, it's not up to the forensic scientists. Just like we don't live like those movie CSI. We don't drive Pampers. We don't eat in a fancy restaurant. We work around the clock. Lucky we have a hamburger. Good questions.
Great questions. And we have quite a few questions, and I want to remind our audience that any questions we can't answer today, we will be answering via email. Dr. Lee, are you up for a couple more?
I think we're already over time, okay?
How about one more question then?
Okay, one last question, okay.
I'll ask you this one. I know you won't be able to have time to talk about it, but what was the hardest case you've had to solve?
That's basically case without information. In other words, we're not called to the scene, nor the physical evidence will collect. You're basically one person's statement versus another statement. You don't have any other direct physical evidence. Those are difficult to solve. I can give you a lot of example, but some other time when we maybe feature to have a serious unsolvable homicide or something. Okay, I want to again thank you, Susan. Thank you, Taylor, Lane, and LabRoots. The most importantly, thank you all those audience. Thank you for listen to my talk, and I wish you all stay safe, healthy, and when you go out, make sure put the mask on, okay? Now I have to leave, so I put my mask on now. Thank you again.
Dr. Lee.
Bye.
Dr. Lee, thank you again, and thank you for the audience for your wonderful questions today. As a final reminder, Any questions that were not submitted will be provided via email. This presentation will be available on demand viewing until November 2020. So please share it with your colleagues who may have missed today's topic. Thank you again for your participation. And until next time, be safe and stay healthy. Bye-bye.